I'm sharing I'm sharing my screen with the presentation, right? You can see that?
Yes, we can see. Thank you.
Okay, great. Okay. Yeah, thanks everyone for having me. And yeah, Anna just wanted me to kind of, as I know a lot of you are building your kits, assembling your mats, and getting started with programming your robots and trying to tackle some of the robot missions, share with you maybe some of the methods that I use in working with the kids and working with the team for writing programs and going after these missions. So I basically kind of set up a couple of tools, a couple of methods for the kids to use in planning out and writing a program. And in order to sort of get them familiar with that and maybe get a little practice with it, I used the guided mission 5 that is provided with this season's materials to sort of walk them through that. And so I'm gonna, kind of talk through that now a little bit to show you what we've done and how we went about doing that. So the focus really here is around Spike Prime robot builds and the Spike Prime app for what I'm covering today. The same concepts and ideas, you can leverage this stuff and use it if you have EV3s, or if you're comfortable with using EV3s, or if that's what your team has. The code will be slightly different. The robot builds will be slightly different. But for me, I've used EV3 for over the past 4 or 5 years, and this was my first experience with Spike Prime. So it's been interesting. I think they each have their pluses and minuses between the two robots, and it's just a matter of knowing your tools and knowing how to work with them to get done what you want to do. So the nice thing with the Spike Prime that is different from the previous EV3 is there's already out here on the web, and I put a link down here, but there's already like these nice building instructions on the web. If you just Google Spike Prime building instructions that show a couple of different sort of education kit type of builds, educational builds that you can do with them. But they do have 2 robot styles down here that you can adopt. One is like a standard driving base. This just has 2 of the smaller wheels with 1 ball at the front to balance it and 1 motor. This is somewhat similar to what like the EV3 basic build is. It's smaller, it's a little more nimble, lighter, might move around the mat a little bit quicker, but it does require a little bit more creativity and effort to build onto it, maybe customize and create some attachments for it, or make it a little bit sturdier or robust. I know on our past teams, our EV3 build started out something like this, and the team had to get creative and build sort of a frame around it, add some attachments, sensors, things like that they wanted to incorporate into their programming. And it took a little bit more time, and things they would make maybe didn't always work well, or they'd fall apart, or they'd have to spend a bit of time trying to get these things to fit into their flow. The nice thing with the Spike Prime is it has this like advanced robot build, so it uses a much larger wheel. It has 2 of the balls at the front, 2 color sensors, and 2 motors at the front and back, which are pretty cool because they sort of have this cage around them. And then it gives you 2 examples of attachments that you can use. And these are really nice too, because they like very quickly eject and install into the robot. And these 2 basic attachments here. These are also part of the instructions on the website. They give a couple of different attachment ideas, things that you can do. But it's nice because this sort of base format for the way the attachment works, the kids can get creative with that and make their own attachments that will quickly slot in or remove from the robot and can provide additional functionality if needed. So this looked like a pretty cool build. This is what the kids ended up getting on my team and what they've started working with so far. So basically, when I started working with the kids, they built all the models for the mat, for the missions, along with the robot that they'll be working with. We kind of as a team sat down and looked at all the components that are a part of the robot, right? The brain, the different motors and sensors, where they're plugged in on the brain, appropriate handling, working with the robot, things like that, so that we don't damage it or it gets worn down and is less reliable for us in running missions, things like that. And then we went into, we did spend some time, we watched the video. There's, if you don't know already, there's a overview, robot game mission overview video. It goes through each of the individual missions, talks about how they're supposed to move on the mat, how the robot, could potentially interact with them, and how you will score points for each of those. We've looked at that a few times just to get them familiar with all the different missions. And then we initially started off looking at sort of some of the basic code blocks in the Spike Prime app. And this is something that you can do with your team as well, but some of the specifics of the code may vary based on your design. So we started off just identifying where each of the motors are plugged in on the robot and what they control on it. Let me connect mine really quick so it shows up. So once you have a robot plugged in, whether you're connected with Bluetooth or with a cable, it does register and show all your motors that are attached to the brain. So we can see here that I have motors on A, C, D, and E, and then there's a couple color sensors on B and F. And then in the Spike Prime, another nice piece about it is it also has a gyro included in it. It's not an external sensor. It is part of the brain, which is nice. It seems to be a little bit more accurate than the gyro on the EV3. The gyro on the EV3 was external, and the readings from it would vary based on where it was placed within your build. So it was a little bit more finicky working with, but it is now just a built-in feature within the brain, and you have some instructions to work with that as well. But we kind of, the first time we got the Spike Prime app going, we sort of built something like this. This is actually, I cleaned it up a little bit after, but these were the snippets of code that we were experimenting with as a team and some of the notes that I took as we talked about them. So the first piece that you would always start your program with, and if you start a new program, you'll see that it always has this orange block at the top for when you push start on the robot. The first code that you'll do is identify which of the motors are essentially the wheels or control the movement. So we kind of identified things and created a little legend here that tells us where each of the motors are, where each of the wheels are, each of the attachment motors, and where the color sensors are. We experimented a little bit with some of the movement blocks, so you can adjust the speed of it with this block for making it go faster or slower, depending on what you're interacting with or how quickly you want it to move across the mat. We have this standard move block, which just has like a forward, backward, left, and right. We experimented a little bit with the different increments, metrics that you can use for defining that. So you can tell it to move in inches and rotations. We found that like inches and rotations seem to be kind of the most easy to comprehend. Usually inches, a lot of people are used to measuring and describing distance in inches. So either of those. And for this, when you choose a left turn or a right turn, it is what is known as a tank turn. So when that happens, both wheels are active at the same time, but they're going in opposite directions and at the same speed. So essentially what you end up with is just your robot spins in a circle, sort of a motion. There's another move block here where you can only go forward, or you can turn in a left or a right turn. You can use this little steering wheel here to define how sharp of a left or a right turn it takes. And essentially what this does is it's a ratio of the speeds between the two wheels. So if you're turning right, your left wheel is going to spin at some degree faster than the right wheel, and it will cause it to make like an arcing turn. However, if you do go all the way maxed to a 100 or a negative 100, it does do a tank turn type of a turn similar to the turn up here. And so those are, strategic in how you want to move your robot. A tank turn is nice because you can drive straight and then you can turn and reposition yourself without moving to another location on the mat. Whereas if you want to incorporate some sort of an arcing turn, you can use that possibly to go around an obstacle or it's a little bit more of an advanced path, I suppose. And then we also have these blue motor instructions up here at the top, and these you can use to control your attachments. So with these, you would want to know if you're wanting to control your front, depending on how many motors you have in your build, which one is it plugged into, and if you have multiples, which one is the front or the back or whichever. You can set the speed with that as well, and then you can. This just shows it as a left or a right, but that essentially translates to like a up or down movement of those attachments. And so we experimented with that a little bit and identified, if we turn right, is that going to make it go up or is it going to make it go down? How much, rotations or inches or degrees rotations or degrees do we need for moving it to a particular position? And then there's more advanced instructions that can be used as well, depending on how well your kids, your team can pick this up. But you can use different logic events in here to wait or to move it to a specific position, things like that you can get creative with. So that was kind of our starting point, and trying to tie together coding with the robot. A lot of the kids nowadays, they learn Scratch pretty early in school, and the Spike Prime app, when you load up a program, it gives you 3 different types of code that you can choose from. You can choose icon blocks, which looks somewhat similar to like an EV3 API, word blocks, which look a lot like Scratch code, or straight Python, which is just code. But with most of the kids being familiar with Scratch, they chose this path, and they're very familiar with working in an environment that looks like this. So that was kind of our introduction to the Spike Prime app, getting familiar with some of the basic code blocks, and then, like I said, relating it. We ran some of these basic instructions and observed how the robot maneuvered with that. For going back to the missions and the specific rules, again, there's the overview video, which is on YouTube. Does a pretty good job of it. There is the robot game rulebook. So with your kits, I think everybody should have gotten a printed copy of this, but there are digital versions as well that you can pull down off of the web. And then you can even, if you're fully stumped on a mission, you can YouTube, look up, FLL SuperPowered mission, whatever. And a lot of times other teams and players will post videos of themselves working on missions, and you can, get some ideas or some suggestions for how to attack a mission. So from this, when you go on the Lego website, so there's the the website with all the resources and everything. There is a guided mission on here that you can download. Yeah, this one here. So this has the actual code for it. It has a little image that shows you what that looks like as well. And so this mission essentially tackles mission 5 for you, which is the smart grid. It's like the little hand on the mission. So the robot just comes out, it pulls on this little red lever, which makes the hand raise, and then returns to the base. This is a nice mission because it's a pretty simple path to go on. And in this code that they give you, they do incorporate some gyro and color sensor usages. And it also exemplifies the use of comments, which is nice and important. You want to try and promote that your kids use comments both for understanding their code, communicating their code, and in their robot design presentation when they want to talk about their robot or their missions. It makes it easier for like the judges to read and review their programs. But for like starting with my team, they're pretty much all new, and this is slightly advanced for them. I kind of simplified it down a little bit more and took out some of the sensor usage to begin with, and then that's something that we'll build upon. Does anybody have any questions so far? So
I see a couple of questions on the chat, but we can address all the questions at the end if people can add the questions on the chat.
oh, okay.
Yeah,
Yeah, that works.
I think it's related to whether they have to buy an expansion kit. Yes, I think you need an expansion kit.
So for I've done this with my past couple of teams now, and it seems to work out pretty well. So I created this planning sheet for them, which just has sort of the wireframe image of the mat onto a piece of paper with some lines. And I print off a bunch of copies of this and hand them out. And basically, I let the kids go and pick a mission that they would like to work on. Identify, where would their starting point be? Well, at least in this season, we have 2 starting points. So where would you start your robot at? Where's the mission that you wish to interact with? And maybe sketch it out, draw out what the path of the robot is going to be. And then from that, write out some pseudocode. So it would just be simple, right? Push start, drive straight, turn left, drive straight, turn right, push the button or lift the thing or whatever you needed to do, and then drive back to home or something like that. So it's just English word version of a program. So we did this with the Mission 5 program. The mission itself is actually back here in the middle of the mat. And so as a team for this one, we all talked it through. We kind of decided, where do you want to start at? And it was a little bit split. So we let the kids raise their hands and vote, who wants to start on the left, who wants to start on the right. And the left side won. So we started our robot over here. And we brainstormed a little bit, talked about a couple of different ideas for paths to take. There were some that wanted to go up this way and across. Some wanted to come all the way around from the right side and approach it. Someone even suggested, why don't we just follow this black line from the start all the way over to the hand, which is a very good answer. That one's probably one of the best options to do, but probably one of the hardest to code. So we ended up choosing just a simple left-hand turn. So the robot starts here from the left, comes out to about the middle of the mat, makes a left turn, and then drives up to complete the mission, and then does sort of a reverse path back into the home base. So we initially, drew our path out, kind of wrote it out in some simple instructions. So drive straight, turn left, drive straight, pull the red thing, turn around to face backwards, drive straight, turn right, and then drive straight. So you're back home. So that was sort of our first draft of the program. And then we went and gathered around the mat and just kind of pretended to do it. So we followed these steps with the robot. We just kind of carried the robot over and let it follow this path, and identified where are maybe some opportunities to refine those instructions and add more detail to it. So we actually ended up taking a tape measure, and we measured how long, if we start the robot at some location over here, how far out does it need to travel? How many degrees do we need to make that 90-degree left turn? How far does it need to travel here, and so on. So then we came back and we added a little bit more detail into the pseudocode here. So now we have numbers to place to go with those directions and those movements. And then from there, we can use that to build our program. So they started out basically just translating exactly what they had written down on the piece of paper into actual instructions in the Spike Prime app. And then once we got this all written, we took it to the mat again, and we started, ran it a few more times. We saw where it was off. Maybe it was driving too far, it was turning too much, or it was crashing into other models. And we just continued to refine those numbers that are in the instructions, as well as refined our starting point, because that was key. And that was a big lesson, that the kids need to learn as well, is that they need to find a consistent starting point. Maybe if you look at the I guess it doesn't show it here, but if you look inside this start area on your actual mat, it has like a grid on it, has like squares on it, or even there's text and things on there as well. So if they can find something to line up the robot and consistently start it at the same location, then it's going to create more reproducibility, as well as they're making these tweaks to their code to fine tune the program, they're going to start hitting success with it. So this was our final program after we ran it, and it went out, accomplished the mission, and came back to home. We added a few comments to it just to help us remember what it's doing, and again to communicate what that program is. And we have a little video here that Anna recorded of one of the successful runs. So yeah, that ended up working out pretty well. So with that completed, I didn't get a chance to yet, but I do plan to revisit this advanced version of the mission to show how that same mission could be done in a different way, but also make use of some of the other sensors, like the gyro and the color sensors. Now it'll be up to the kids and how much they're able to follow and understand that to incorporate that into their own missions. But it's always, it's more tools at their disposal that they can use to make the program, a little bit more advanced, a little bit more robust, and greater chances of success. And of course, and I'll send all this out. You guys can have all this to review. But a lot of this will depend on your specific robot build, the size of the wheels, the size of the robot, the weight. A lot of those things will play into these numbers that are being used. So you can start with a rough idea of a program and tweak it to make it work for you. But definitely, these concepts can be used with your team for any of the missions. So with these skills, I hope to allow them to go through and identify missions that look interesting to them or challenging to them or whatever it may be that they want to work on their own. Hoping in the next couple of weeks to have each kid maybe working on 1 or 2 missions of their own, and planning them out to get success based on the existing attachments that we have. If they need to do something different that those attachments don't provide, they can always design and create their own attachments to put on the robot. Another popular or thing that works well is a jig or something that can help with aligning the robot. I think I know, I had a picture of one I found. So this was another team. They had created this big piece that helped, since the robot is off-centered from the wall, or offset from the wall a little bit, they use something like this to help line it up so that they had a consistent starting point, something that they can push the robot up against and have it start in the same direction in the same place every time to make more consistent results. And then the other thing you can do is, once you have maybe a few missions, and if you have some more time to work on it, you can try to combine missions to save time. So if you're out doing one of the missions and there's another mission just next to it, you can try to get it to scoot over to the next model and complete that one as well before returning home. That way you get more points in the time that you've spent out on the mat.
This is great. Thank you, Alan.
Uh-huh.
I like the approach of first having them write down the pseudocode, just move forward, turn left, turn right, and then go into the coding piece. I think that's a wonderful idea.
Yeah, it helps them out a lot to sort of think the mission through at first. Because in the past, if they just start out with a blank slate and they start trying to write code, they get frustrated, or they end up writing a bunch of code that gets them into more trouble than they need. So if they can think it through and from the beginning, and then try to simplify it before getting code into the robot, it seems to make it easier and more successful.
Absolutely. Yeah. Thank you. Let me stop the recording.
Mm-hmm.